panelists because just like you, I can ask them all the tough questions. All right, so we'll get started. I'd like to invite our first panelist, John Granger. John is the General Manager for Business Technology Practice within Global Business Services at IBM. So he's responsible for making sure that he can leverage all the various technologies and tools within IBM, including Watson. Next, let me invite Pat Geary to come across. Pat is the Chief Marketing Officer at Blue Prism. And Pat is also the individual who is responsible for coining the term Robotic Process Automation, or RPA, in 2012. So he's the father of robotics, so we'll hear from him. And the last panelist for us is Adam Devine. Let me invite Adam to join us. Adam is the Vice President of Marketing at WorkFusion. WorkFusion is a relatively young company, only 5 years in existence, which basically leverages some technology that was created at MIT. The way Adam describes it, when he joined, he thought robotics is going to overtake the world and substitute all the service providers. And now he thinks service providers can be his friends and actually the channel to go to market. So we look forward to that. Adam, incidentally, he just went for a safari to Jim Corbett Park, and after this he goes to Kerala for surfing. So he's kind of has a short stop in between to do this panel discussion in between his safari and his surfing activities. All right, for your viewpoint on this.
Sure. So before I get into the practicalities, I want to start with some fundamental philosophical beliefs that I have and that our company has, WorkFusion has. The first one is that the mind is plastic. For 500 years, we've fundamentally had the same brains, but think about how we've evolved, how we've used them in the last 500 years. It's been exponentially different. So we truly believe that AI is going to make people better at what they do, not replace what they do. The second point is that the invention of one is the platform of many. So we, Pat's team, we've all built technologies that are incredibly disruptive and that can potentially change the way business functions. And actually Rohit mentioned just a minute ago that I naively thought when I first joined the company 3.5 years ago that we would fundamentally disrupt and even replace the services business. Total naivete. Just like our customers in banking, healthcare, e-commerce, etc., the services world has embraced the platform that we have built, and they've made themselves better on it. They've innovated on top of their platform and added their own unique IP. And then the third point that I'll make is that the definition of services is to provide value to the customer. And I have a very strong belief, we all have a very strong belief, that the services world will take this innovation, will take this exponential power, and redefine what it is to provide value to their customers. So as far as the practicalities, we all got dressed this morning, right? So getting dressed is a process. Putting on your socks, pretty robotic. You don't really have to think about it. You don't use your brain for it. That's kind of what robotics does. It takes a very simple, you almost can't even call it a process, a step within a complex process of judging the weather, thinking about the occasion you're dressing for, bringing in your own sense of taste, putting on a full clothes, putting on all your clothes. But if you walked outside in just a pair of socks, what would you be? You'd be naked. So that's robotics, just putting on a pair of socks. Cognitive is much more nuanced. It's much more focused on the entire end-to-end process of judging the weather, thinking about what you're dressing for, bringing in your own taste. So, back to the whole point of the conversation, AI, cognitive computing, it's a much more disruptive technology than just robotics alone. And it is something that we're all going to be talking about for the next couple of years because it's a much more exponential technology. In terms of the practical definition of it, if you think about document processing, how many people have received a document via email or an FTP site, opened it, judged it, extracted from it? I know that's pretty much all I did my first couple of years in management consulting. So if you think about that end-to-end process, the first step is grabbing that document from a source, whether it's an email or an FTP site or a database, and putting it someplace. That's a robotic process. The middle part of that process, the prioritization of it, the categorization of it, the extraction part of it, this is like 90% of the value of the process. That's what cognitive does. And then the last mile would be transforming it from, say, a CSV file into a JSON or some kind of end state. That's a robotic process. So I think it's important in the context of this conversation to really clearly define what robotics is and what true artificial intelligence and cognitive computing is. So that's my initial perspective.
Okay.
Along with my colleagues, I mean, clearly we see that cognitive computing systems are going to be extraordinarily disruptive. And indeed, you know, we at IBM have gone so far, we think it's so significant that we're calling this the third era of computing. Cognitive computing is going to be the third era after tabulating and after programmable. And in a nutshell, what we're seeing is that these cognitive systems are probabilistic rather than deterministic. And I think, you know, the key characteristics for me are their ability to understand unstructured data. I mean, in this data explosion that we're all, you know, that we can all reel off statistics about, 80% of that data is unstructured and is currently invisible to computing systems. But cognitive systems can actually understand that data. They can see. You'll see Watson on the fringes here has the capability to ingest images, medical images. They can read. Watson can read in different languages and can actually take the natural text, all of the words that we put into books, and actually pick that up and ingest that. And they can also hear. They can hear natural language. And along with that, as well as understanding unstructured data, cognitive computing systems can reason, they can put forward hypotheses, they can give you the probabilities of success of those, and finally they can learn. I mean, these are not program systems, these are systems that experts train, and they learn constantly. Think of Watson in the Jeopardy game, it was trained to beat the humans. And so I think the transformational opportunities for our clients are just enormous, absolutely enormous. I'll give you three really practical examples. I think through cognitive computing systems, we can elevate and scale expertise. I mean, if you think about professions, it takes about 16 years to become a decent doctor, 10 years to become a law partner. And yet there's enormous variations in the competence of these professionals. I mean, they reckon that with doctors, between the best and the not so good, it's a factor of about 6. For sales professionals, it's 8. For developers, it's 9. And yet at the same time, with these variations, you've got an explosion of the data that's available to people. So take the medical profession, for example. I mean, in 1950, they reckoned that it was going to take 50 years for the amount of medical knowledge in the world to double. By 1980, it's doubling every 7 years. Now it's less than 3. So how do you square this circle? Well, cognitive systems can do that because they can bring the professional to a level of competence much more quickly, but they can also democratize. I think this is a really important point. They can democratize knowledge because the best of the professions can actually teach and train the systems in order to ensure that everybody is brought up to a higher level. So a very practical example for us in oncology, for example, around this, in Brumgrad Hospital in Bangkok, on oncology consultants, they see about 3,000 patients at any one time. They can give them 15 minutes each. We've developed Watson for Oncology, which actually is an expert system trained by Memorial Sloan Kettering, some of the best experts in the US, making that available to patients within Southeast Asia. And we're going to do the same thing in Manipal Hospital in Bangalore, I'm very pleased to say. So then, if that elevating and scaling of expertise is one use case, another would be improving on exploration and discovery. I mean, think of all your clients that take big bets, big pharma, oil companies. If you want to open an oil field, there's 600 petabytes of unstructured data you need to go through in order to work that out. And you think of the opportunity to speed that process up. So we worked with a pharma company, for example, to look at 24 million documents, 70,000 individual journals in order to identify which proteins are changing cells to a pre-cancerous state. And normally these researchers will read between 1 and 5 journals a day. So that sort of process, normally 7 years, done in less than 10 weeks. I mean, those sorts of opportunities are enormous. And the third use case, I think, on top of the scaling of expertise and the ability to move into exploration and discovery. The third use case is how you deepen human engagement. So as man interacts with machines, we're all aware of the transactional data, the place, the transaction history, and so on and so forth. But these systems can detect tone, they can detect sentiment, and therefore you can adapt and tailor your response to the human that's interacting with your system much more effectively. So again, practical example, we've been working with schools where you can actually take structured and unstructured data about how pupils are progressing and then tailor the learning experience for those kids in order to ensure that they have a better success. You can tailor the type of learning that they're going to do, but you can also start to pick up what the warning signals are where they're going off track. So I think the transformational opportunities for our clients from this technology are enormous, and we will be able to do great things for our clients in order to help them to take advantage of that.
That's something which everybody in the audience is very keen to know. I am keen to know because I'm paranoid of this stuff and would love to get to hear your perspective and see what you have to say on this.
Well, firstly, the University Oxford Martin report, it was 47% of jobs were susceptible to automation. It wasn't eliminated.
Absolutely.
Yeah. And they looked at 700 different job types, and I think the most likely to be replaced was a data entry clerk, and the least likely was an occupational therapist.
Yes.
And they looked at a very different range of skills. And I think it's really important that we look at human skills and we look at computer skills. Now, searching through petabytes of information, that's not a human skill. That is a computer skill. Always has been, always will be. And so I think what will happen is we'll see the types of work that people are doing. We have a saying, we take the robot out of the human. And it isn't just the rote work, it's the stuff that is not good for human minds to work with. We have cognition, we have context, we have creativity. And I think the first one is just totally ridiculous. There won't be an AI machine on the board of a company. They might use technology to help them take decisions.
The data is, there is a company which is an investment management company. They already have a robot on their investment committee. So investment decisions that need to be made by the committee,
but that's
one of the inputs, not the only input, is already being provided by a robot.
But that'll be a Monte Carlo simulation.
Okay.
I'm going to step in here because I'm not sure I want to pick up the margins and growth thing, but you can work out how these questions are going down the line.
All right. So maybe we just talk about jobs with the three of you.
But I think there's a commonality of view. Adam said it as well. I don't think any of us think that these cognitive systems are going to replace human beings. They can't. What they are going to do is to really assist decision making and to help us make better decisions. So there may well be somebody robotic on the board of the bank, but that's to assist a better decision. And I think what's really interesting in this is I think one of the things it may do for us in the 21st century is actually change our conception of what an intellectual contribution is. Because I think what this is going to do is to actually, previously there was an element of, your intellectual contribution was measured at least in part by what you know, yeah? And I think actually cognitive systems are going to commoditize that, if you will. And actually what's going to become more and more important is going to be what sort of questions you ask. Because when you have that amount of power that you can put in service of your questions and your hypotheses, then I think your ability to spot those opportunities is going to be really important. So taking that together and building on Pat's point, I think the opportunity here in jobs is, we're all going to have to reinvent ourselves. Everybody's going to have to upscale and move, and that's always been the case. Throughout time.
Right.
The whole purpose of technology is to remove the menial from what human beings do and to free them up to do the more higher value stuff. And I definitely think, and I'm sure Adam does too, that's that's where the opportunity lies. Not easy, but I think we will be able to create a lot of opportunity for everyone from that.
I couldn't agree more. Like when you think about
Adam, let me just comment on Pat and John, and before I allow you to talk about it. So what Pat and John have said is absolutely right. If you look at it historically, right? Historically, in the US, in the turn of the century in the 1900s, 90% of the people were involved in agriculture. And today, only 2% of the same population are involved in agriculture. The output is the same. We all get to eat, all right? And everybody's moved up. Everybody's standard of living has gone up. So every time this kind of an industrial revolution has taken place, and there has been a substitution that has taken place, there has been other roles and other jobs that have been created which people can move on to and do that. So Adam, now let me throw the challenging part to you, which is this time is it different? Because, and let me try and set the context on this. This time, when the substitution is taking place, it's taking place at a much, much more rapid pace. That's number one. And number two, you think about this as disruption or displacement and consumption. So the economic theory is that any job that gets substituted or gets eliminated basically reduces, is a supply side factor that's getting, created. And then there is demand for more products and more services, and that creates new types of jobs and opportunities. And we can see examples of that. So for example, when the iPhone was introduced and smartphones was introduced, there never used to be these apps. And now there is a whole app economy which has been created, and that's a $100 billion economy that's been created. And there are a number of new jobs where people are writing apps. But the issue is the number of people that are required for $100 billion of apps is far fewer than the number of people that get displaced. So the question to you really is the opportunity for the demand side going to be as strong as the disruption on the supply side?
I don't want to answer that question. It's too hard. So I want to actually steal a point from one of my favorite books, which everyone in this room should read at some point. It's called Race Against the Machines, and it's by two seminal thinkers in artificial intelligence from MIT. They're friends of our company, by Eric Brynjolfsson and Andrew McAfee. And the book initially paints a really dire picture of what the world looks like with AI once it scales. Massive job loss, and this extended period of difficult adolescence where we're trying to figure out what the value of human intelligence is in the context of AI. But at the end of it, it ends in a really optimistic note, and it says that the cost of really everything is going to precipitously drop, and it's going to enable people to work less for the same quality of living. So that's, if we really want to talk about macroeconomics, couldn't agree with that more. Maybe it's a little far off. Maybe we're going to have a period of, like I said, kind of awkward adolescence where we figure out what our roles are. But I want to make that point. The second point is that the first time an exponential power comes into being, there's a lot of doomsday predictions about what the impact will be. Look at splitting the atom. What was the first thing we did with it? We blew stuff up, but now we use it to power a lot of different cities. So I think AI kind of has the same thing. We're looking at it, we're running the numbers, we're not taking into account the relentless drive for humans to find value in every day. And I think the same thing is going to happen with AI. We're looking at the potential downsides of it, but we're not thinking creatively and practically about the potential upsides. So I want to talk just for a minute practically about what I see with our customers. There are customers that come to us and they initially say, we want to cut 1,000 heads to save 20% on our margins. And then they start to use it and they see that it's another way of building capacity. And they see, and I think one of you guys made the point about moving from the back office to the front office. It's not about reducing the total size of heads, it's about shifting the back and middle office functions to the front office to drive more customer value. So if I didn't get specific enough in answering your question, ask me the hard question again really specifically and I'll try to answer it.
All right, I'm going to actually ask the audience to ask all of you some questions.
The exciting thing is when we move from von Neumann style computers, which we have today, which are essentially binary computers, to quantum computers. And that's when massive amounts of data into exabytes and petabytes, exabytes and zettabytes can be computed almost instantly. And that's very nascent technology. That could dramatically move things forward. but that's I think really far out there if you want to look very far into the future.
All right, Adam, 30 seconds or less.
AI will elevate the application of human intelligence by automating the work that should be beneath it.
Great, that was perfect.
Yeah, when I was thinking about this, I came across a quote by Thomas Watson Jr., who was the former chairman of IBM, and he said this: "It's time to get this whole problem of men and machines under a blazing noonday beam. Computers will never rob man of his initiative or replace the need for his creative thinking, and by freeing man from the more menial or repetitive forms of thinking, computers and computing systems will actually increase the opportunities for the full use of human reason." And I think that sums it up for me.
Great, thank you.
Thank you so much, gentlemen. As you can see, it's an absolutely packed house, the most popular session that was on. Let's just say we have to ride the tide of restless innovation, and we let the future tell us the story. I think in the next edition, the 34th, we may actually have a robo sitting here on the panel, and we may have him being interviewed. So thank you so much. As a token of our appreciation, I'd like to request you to hand over photographs and the mementos to our speakers. Ladies and gentlemen, Pat of Blue Prism, Adam from Work Fusion, and John from IBM, and of course, Rohit. Thank you so much for chairing the session so beautifully.